right, so first of all, some of you who have chemistry have some experience with logarithms. If you didn't do chemistry, then we're going to start from scratch anyway, so it's all good. What I want to do is, if you have a graphing calculator or any calculator, get it now because it's going to help a lot on this video, and you actually won't be able to do the second video or some of the first video without a calculator. So stop the video and get a calculator if you need one. And I'm going to use my graphing calculator here because what I want to do is I want to just mess around with logarithms a little and just see what do we notice about logarithms. So we have our log key, our ln key. We'll talk about those two, what they mean, how to use them in the second video as well. But let's just try doing the logarithm of a number. So if I do log of 8, it gives me a decimal less than 1. If I do log of a number less than 1, get a negative number. What about log of 0? Oh, that doesn't work. I have a domain issue. Notice it says we'll talk about that in class. What about the log of a negative number? Oh, non-real answer. That's not going to work. Okay, what if I do log of maybe 100, a somewhat bigger number? It brings it down to 2. Log of 1,000 brings it to 3. We'll talk about why it does that, why it's a whole number. What about log of a big number that's not a multiple of 10? It brings it down to a small number. So that's one reason why logarithms are useful. Logarithms make large numbers more manageable and easy to work with. So that's one reason why people use logarithms. If you're dealing with really, really big numbers that are very, very far apart, if you do the log of those numbers, they become much smaller. Another reason why we need logarithms is the following. So let's say, all right, we know what 3 squared is, we know what 3 cubed is, and 3 to the 4th. So these numbers we're very familiar with. What if I wanted to know what exponent of 3 would give me 40? So obviously it's going to be in between 3 and 4, this mystery exponent that I'm talking about, but I don't really know what it is. Now realize that if we were really desperate and we really, really had to know what exponent of 3 gave us 40, what we could do is just go to a calculator and just pick numbers between 3 and 4 to be a power of 3, because we know it has to be between 3 and 4. I started halfway. It's too large. I do 3.4, still too large. 3.3, oh, now that's too small because I want 40, so I bump it up to 3.35, getting closer. Notice if I do this exponent, I'm pretty close to 40, but again, it's not exact. So I just kind of summarize the results here. But again, this is a waste of time, and we don't want to have to do this if we need exponents. So what mathematicians did, John Napier, this mathematician I named here, he's one of the ones that came up with the name and was responsible for defining logarithms. This x value, the mystery exponent, is defined using a logarithm, and it is written as log base 3 of 40. Now notice when you write a logarithm, there is always a base. Sometimes a base is not written, and we're going to talk about why that is. Even if it's not written, there always is a base, and the base needs to be written smaller. And this larger number is what you're doing the logarithm of. So notice an exponent is defined with a logarithm. So exponents are really just logarithms. Don't make it harder than it is. Some people make it more complicated because they don't like the notation and it's new and they're uncomfortable with it. Just keep in mind logarithms are exponents. So here's a definition you need to know. Log base b, which is right here. You can convert, it's basically defined using exponential form. If you have x equals b to the y, that's equivalent to y equals log base b of x. So exponential form and logarithmic form. So again, you say y equals log base b of x. And this is what you're going to use to convert from one form to another. And that's the first thing that I'm going to have you practice. You have to be able to convert back and forth and be comfortable with logarithmic form. So let's start right here. Converting from exponential to logarithmic form. Let's take a basic exponential statement. We're very comfortable with this. 2 cubed is 8. You've known that for a very long time now. If I'm going to convert it, some people like labeling it at first until they're comfortable with it. X equals b to the y. Here we go. Then y equals log base b of x. So 2 is my b here, my base. It's raised to the y power, so 3 is my y, and 8 is my x. Okay, x equals b to the y. Then y equals log base b of x. And I just fill in the 2 in place of b because I already called it b. And I replace 8 with x because that's what I called it here. And the logarithm equals the exponent. Okay, so notice the exponent is what the logarithm equals. And then this red bar just says the base of the exponential form is the same as the base of the logarithm. So I want you to write these 4 more down, pause the video, and then convert them on your own. So fill these 4 out, and then come back to check your work. All right, so by now you should have attempted these 4 on your own. Please check your work here. Now what I want you to do is I want you to look at these logarithm statements and see if you notice something about the numbers. Because our eventual goal is to evaluate these in our head. So for example, find what log base 4 of 64 is. Alright, so let's pretend that we didn't know that log base 4 of 16 was 2. Well, we know it is 2, but let's think, how could I get 2 just from 4 and 16? Or for example, pretend you didn't know this was 3. How could you go from log base 5 of 125? How could you look at these numbers and get 3? Same deal here. So I want you to stop the video, think about that, or in your mind, think about this right now. And what you should come to the realization of is that whatever the base is, you need to raise it to a power to get this number, and whatever that power is, that's what the logarithm equals. So for example, 5 to what power is 125? Oh, it's to the 3rd power. So the logarithm equals 3, because remember, logarithms are just exponents. 4 to what power 16? 2. So we're going to be evaluating these things mentally just like that. Just take these notes down right here, just these little sentences. Logarithms are just exponents, remember. And logarithms, and I'm abbreviating exponents, the 2 cancel each other or they undo each other. That means they are inverses of one another. And when we come back after MCAS, we're going to spend about half a period talking about inverses because that's a really important math concept. Okay, so let's talk about evaluating these things in our head. Well, we already realized that logarithms are just exponents. So to evaluate this, oh my god, go away. Okay, so to evaluate this logarithm, what I need to think is, all right, log base 4 is 64. I need to know what power of 4 or what exponent on 4 would give me 64. 3. So log base 4 of 64 is 3. That's it. Just think of what exponent you need to give the base. So knowing that, why don't you give these 7 a shot? So pause the video again, try these on your own, and then when you've done them, come back and check your answer. So make sure you're pausing right now. Make sure you're actually pausing the video. Alright, these 4 are pretty easy, not too much to think about there. These 3, though, are the more interesting ones. So I don't know if you struggled with this or not, but let's see. I want to know 4 to what power is 1 over 16. Well, it'd be really nice if it was 4 to what power 16, because that's easy. It's just 2. But it's 1 over 16. So then you have to think, how do you go from a number raised to a power to a fraction? And then hopefully you're thinking, oh yeah, remember, like what if it was a negative exponent? 4 to the negative 2 is 1 over 4 to the 2nd power, which would then be 1 over 16. So the power that you have to give 4 is negative 2. So that you have to think about when you look at fractions here. Then notice that all of these examples, the base was smaller than this number here. But look here, the base is bigger than this number here. So how am I going to go from 16, raising it to a power, to a smaller number? That's weird. Is that even possible? How are we going to do that? What you should have thought is, oh, I can raise it to a power. Going from 16 to 4, I really just do the square root of it. And you should know by now that doing the square root of something is the same as raising it to the 1/2 power. Okay, this one's weird too, because 2 to what power is a negative 8? Well, 2 to the 3rd is positive 8, but I don't care about that. You might be thinking, oh, what if I raise it to a negative power? But look, 2 to the negative 3rd is 1 over 8, not negative 8. This is just not possible. D&E, you can't do it. Can't do the log of a negative number. Maybe we should write that down. Can't do the log of a, I'm abbreviating, negative number. Okay, jot that down, and when we come see each other in class on Thursday, I have a PowerPoint of a bunch of these mental evaluations, and I'll call on people randomly to go through it.